Welcome to 1 Minute HKDSE Physics. Today's our topic will be force and motion, the equations of uniformly accelerated motion. Concept: equations of uniformly accelerated motion. Note that these equations are only valid under uniform acceleration. Start with the first equation. A equals to v minus u over t, where a is acceleration, v is final velocity, u is initial velocity, and t is time. This equation is the definition of the acceleration. The next two commonly used equations of uniformly accelerated motion are s equals to ut plus half ad squared, and also v squared minus u squared equals to 2as. For these three equations, it will be given in the HKDSE paper 1a, the appendix part. For equation for the s equals to half bracket u plus v times t, this equation is not given in the public exam, but is seldom used. So when you do this type of question, just remember that you always change the units to meter per second, but not km per hour. And also, you have to put time in seconds and the displacement in meters, and be careful that the acceleration, displacement, initial, and the velocity are all factors. That means you have to define the direction and then to determine whether you put positive or negative. For these four equations, mainly you just have to understand what symbol represent for what meaning, and also just always be careful with your units to make sure they are in the right units before you use it. You don't really have to know how to derive this equation except the a equals to v minus u over t. That is the definition of acceleration. Now we shall go for a practice question. Here's our question. A car is speeding and travels at 90 kilometers per hour constantly. A police car at 80 kilometers per hour is at 10 meters behind the car. The police then accelerated uniformly at 5 meters per second. Find the time when the police car reached the speeding car. Hint: please first turn the 90 kilometers per hour into meter per second. So we do the unit conversion first. From kilometer per hour to meter per second, we change to how many meter per second. That is, for example, for 90 kilometers per hour, we first put 90 times 1000 as 1 kilometer is 1000 meter, and then 1 hour is 60 minutes, and 1 minute has 60 seconds, so 1 hour has 3600 seconds. After doing the calculation, we can find this speed in meter per second respectively. Now we shall consider the situation and determine which equations to be used. Let's look at the case. So here's the speeding car, which is 10 meters in front of the police car, and we know the acceleration of the police car, and then after some time the speeding car is still travel at 25 meters per second, but the speed of the police car is unknown. So in this case, what can we do? Let's consider like this. One thing we definitely know for this question is that the distance from here, that is the police car here, to this point is the same for both car. Then we can consider the distance traveled for both car respectively. Let's consider the speeding car first. Firstly, it's 10 meters in front of the police car. Then we can use S equals to ut plus half t squared to find the period that the car traveled. And as the acceleration for the speeding car is 0, so we can simply put 10 plus ut, that is 10 plus 25t. Then we can now consider the displacement for the police car. Once again, we use the equation S equals to ut plus half at squared. We can plug in the equation, that is 22.2t plus 2.5 t squared is the displacement of the police car. Then we earlier observed that both of this distance are the same. So we can put a equal sign here. So we can now just solve for t and we will have the answer. So after solving this quadratic equation, we have t equals to 2.64 seconds that already corrected to 3 significant figures. So this is the end of today's video. Thank you for watching.